Hello, welcome everybody. This is the Boston Healthcare Cloud Technology community, and my name is Diana, and I'm the community manager of our user group. This is a Wednesday, and we, as usual, want to introduce our community for all those who are new here watching us, maybe right now live or on demand. So we serve the global healthcare technology community from our location in Boston, but providing industry experts and community to share in healthcare technology topics. We meet twice in the month on Wednesdays, virtual like today, the second Wednesday in the month, and in person in real life, the fourth Wednesday of each month. Usually we go to the Microsoft offices in Burlington, Massachusetts. So if you are local in Boston, come join us. You will find more information about our meetings in our website, www.boshug.com. And so moving on here real quick, we want to thank to our biggest sponsor, Real Activity, and also acknowledging the support from Microsoft. If you are interested in join to our community, we have a big community and it's growing. It's really fun. In Discord, we own the Discord server /healthcare. So you can see the URL on the screen. We usually share all the content and share different discussions about healthcare technology over there. So you're more than welcome to join there. And of course, our mailing list. Just go to our website, BOSHUG.com, and you'll find all kind of sources and content from there. So thanks for joining today. And now I'm going to introduce our speaker guest for today, Tony Witt. Let me bring him up on virtual stage. Hello.
Hello, hi. Thank you, Diana.
Hi.
So I'm Tony, and a little bit of background on me. So I've been writing about AR, augmented virtual reality, as well as blockchain, Web3, things like that for a little while now. Now I'm actually starting my own company called Cosmo Labs, and we build basically custom web-based AR like advertising solutions. So if you want to learn more about that, connect with me on LinkedIn, or you can send an email to me down there. That's my email address. Yeah.
All right. Yeah. So today we're going to talk about decentralized science and Web3, which is really amazing. And I don't want to take too much time from you. So please, you can.
Awesome. Yeah, I'll just jump into it. There we go. Yeah, so I want to talk about kind of an interesting application area for blockchain that you might not have heard about before, which is DeSci, or decentralized science, which is really all about how blockchain technology impacts science as an industry and the scientific research process. And of course, like one of the big ways to understand big picture concepts like Web3 is actually really looking at concrete real world examples. So even though we're looking at a pretty like narrow specific topic, DeSci, I hope that you'll come away from this talk with just some general insights as to like the ups and downs of blockchain technology overall and how it can like actually provide value to real industries. So my journey in DeSci began at a conference in Paris about a year ago, where I met the CEO of a biotech startup. At some point during the conference, he pulled me aside and said, like, Tony, our industry is really tough. And I was like, yeah, I mean, I can imagine. But he said, our model relies on cutting edge research and intellectual property, but the universities here in Europe are like IP holding companies. They make it very difficult for to essentially spread and deliver their research to startups like us to turn into products to actually bring to market. So like siloed into these institutions like universities potentially life-changing discoveries, whether that's drugs or research in material science or sustainability, are actually unable to impact the real world and benefit the researchers who discovered them. So, this was, like I said, met him at a conference, and at this point, like, it was late, I was tired, so I didn't really think much of his words at the time. But it kind of stuck in my memory, and I decided to kind of take a closer look into it and find some of the issues that is actually plaguing modern science. So that's what I did. And I found 3 really core issues with modern science. And the first is transparency. The CEO was telling me about the long years that his team spent trying to just find and license the right patents in order to actually build his product. And really the issue is this. On one side, you have research institutions like universities, labs, scientists, and then on the other side, you have companies, investors, startups, entrepreneurs looking to turn research from this side into products, into companies, right, that actually have real world impact. But between those two sides is like a 20-foot high concrete wall. And part of this is really just due to the inefficiencies of university tech transfer offices, or TTOs, which basically manage the IP that a university generates. And these TTOs are generally like bureaucratic, and they're just not set up for commercialization. So as a result, a lot of like valuable and innovative research results stay locked into these TTOs and actually depreciate and eventually just expire simply because they were never transferred away from those offices and into markets and into companies, right? And of course, also like professional researchers typically aren't entrepreneurial in nature, so they often like struggle to show the business value of their work and gain private funding, which I'll talk about a little later. And the second issue is the so-called valley of death, which can basically be described as this. Research obviously has to go along a funding pipeline, and they start with grant funding, right? Asking for basically free grants from universities and governments. But at a certain point, as research projects continue and the team has to scale, it just becomes too expensive to continue funding on grants alone. So researchers have to start looking to additional funding sources. And that really the next step after grants is private investment. But a lot of these research projects are not profitable enough in the short term to actually garner this private investment, and researchers struggle often to show the real value and the business value and actually pitch to these investors to help garner some of that private investment. So a lot of research projects actually die in between these two growth stages, right? In between grant funding and full private investment. A lot of research projects that would actually be cool if they turned into companies and products. But things that just due to the nature of capitalism just kind of die in between those. Hence it's called the valley of death. We need some sort of funding solution to bridge that gap, right? To make it easier to transition from, just grant proposals and grant funding to actually full private investment. And the final issue is actually getting grant funding itself. An article from Scientific American pointed out recently that researchers spend on average 40% of their working time filling out grant proposals. 40%. Think about where humanity would be now if that 40% of their working lives were reallocated to doing actual research, right? And making discoveries in medicine, material science, epidemiology, sustainability, right? Instead of just filling out paperwork to secure funding, which is really not their jobs, what they actually trained years to do, right? In summary, there's these just massive inefficiencies across the board in how research gets turned into real world impact. And to solve these issues, we need some way for researchers and labs and universities to more easily transfer their work and their IP, their intellectual property, to startups and companies and investors. There we go. Yeah, and it turns out actually that blockchain has emerged as a potential solution to these problems. And this realization has marked the birth last year, basically, of the so-called DeSci movement, or decentralized science, which you can kind of think about like the creator economy of academia. And the goal of DeSci is really to use blockchain technologies like NFTs, DAOs, or tokens to unleash research from these IP holding silos ease the funding process for research teams, reduce reliance on intermediary bottlenecks like the academic publishing industry, and just generally increase collaboration across the field. And I know that terms like NFTs, Web3, DeSci, like these are buzzwords, right? And they're often thrown around nowadays without proof of like how they can really provide concrete value. So to kind of avoid that today, I'm just gonna point out 3 concrete ways that these can actually impact modern science. And the first is the IP-NFT. So most of you have probably heard of NFTs, and if you're maybe not so familiar, you've definitely at least seen like the pictures of like these Bored Apes, which is, they're a little ugly in my opinion, but they sell for like hundreds of thousands of dollars on like OpenSea. But actually art, digital art, I mean, if you can even call this picture that, is really just like the first application area of NFTs. NFTs are actually much more data agnostic, meaning you can really attach various types of digital content to them, from videos to text to even research results, and more importantly, IP licensing agreements, which is essentially what an IP NFT is. It's just a way of bringing legal agreements of intellectual property onto a blockchain and wrapping it into this NFT framework. And you can do that by like literally just attaching digital files like the license agreements, contracts, as well as like the research data itself to an NFT. And this kind of IP NFT framework has a couple advantages, and I'll just dive into some of those here. The first is that ownership of an IP NFT can actually be fractionalized, meaning multiple parties can own it, which can be useful, for example, like if you want to distribute a fraction of ownership of the research results of a laboratory to each member of that laboratory, right? And that helps like align incentives to doing the research well and producing good results. And it's also nice, this fractionalization also allows like smaller parties and individuals to actually contribute and own a part of the future of that IP or that discovery or that research. Like typically individuals aren't able to even like invest or participate in this funding process because you would need like hundreds of thousands or like millions of dollars to actually like license valuable IP, and usually only like big pharma companies or big companies have that ability. So fractional ownership of IP NFTs actually solves that. Another really awesome thing is that IP NFTs make the transfer process a lot easier. So instead of like sending back and forth a million DocuSigns to like sub-license IP, you can actually just purchase the IP NFT and get access to the IP with all like legal processes essentially completed programmatically. And yeah, of course, like the sale price that you issue the intellectual property for goes directly to the researchers without an intermediary taking a huge cut. I had the chance recently to talk to a company called Molecule, and they're doing really awesome work. They built a marketplace around IP NFTs, and last year they actually did basically followed through this whole process that I just described of issuing and selling an IP NFT, which was based on a drug discovery from the University of Copenhagen, and they sold it for I think 200,000 US dollar coins, so the US dollar backed stable coin. There's a couple more advantages that I want to touch on with around the IP NFT, and first is traceability and auditability. So of course, in this process of like transferring IP, licensing, all that stuff, legal entities aren't fully out of the picture. Now you're still going to need lawyers. There's still going to be contracts, but their jobs of like navigating legal disputes becomes a lot easier if all the data surrounding that transaction is stored permanently and immutably on a blockchain. And another advantage is just general liquidity. An NFT-based marketplace for IP, like I mentioned, lowers the barriers for entry for investment, again, because of fractionalization. So you can even invest, say, I don't know, $100 or $1,000 if that's all you have into like a piece of intellectual property or a research result. Again, also because of the transfer process, because it's easier to license. It's just on an open marketplace. It becomes a lot easier to participate in that economy. And for those reasons, it also helps bridge the valley of death and helps avoid a lot of time on the researcher's part to spend filling in grant proposals, because they can actually get funding by issuing IP NFTs, right? So they can just take the IP that they generate from their lab and wrap it into this NFT framework and sell it directly on an open marketplace, with relatively easily. Yeah, so the idea is that it would be much easier for people like the CEO of that biotech startup in Paris to find and acquire the intellectual property that they need to build their product. And they don't have to go through intermediaries. They can just buy it directly from the researchers themselves. Okay, moving on. So the second pillar of DeSci that I want to kind of cover is this is DAOs, right? So decentralized autonomous organizations, which are basically digital-first communities that use blockchain-based tokens to coordinate that community to collective action. For example, you might have, well, yeah, I'll give an example. Vita DAO is a science-based DAO, which is hasn't existed around for too long, but they do some interesting stuff. And they basically pool funding for longevity-focused research, hence Vita DAO. And in this, they basically collect researchers that focus on longevity research, and they pool tokens together. And then that central collective pool is redistributed to projects that focus on longevity. And the redistribution, like the allocation of that fund is decided on by voting of the members. So it really allows like individual researchers to participate in the funding of research projects rather than just having big pharma institutions or big investors be able to do that process. And the tokens that are running around in DAOs, they might represent money. They could just be straight up like cryptocurrencies, but they could also represent something like reputation, right? Where members of the DAO can, for example, see like which member has been accruing the most reputation tokens, for example, by doing tedious tasks like peer reviewing or just being active in the community or helping others out. And this kind of framework is also really helpful, for example, for students and entering professionals to help get their foot in the door, because they can start completing smaller tasks like data cleaning or whatever else to be rewarded with reputation tokens, which can increase their visibility in these like networks of professionals. And as I mentioned, these DAOs also let like a diverse set of people, from researchers to patients to just hobbyists and anyone else really, to actually pool their funding together and fund the research that they want to see succeed. So instead of only having the vision of big pharma companies or large investors really make visions come true, we can actually have the people on the ground, the researchers, the patients, the ones who this research is for and who it affects. They can actually participate in this funding process using these like structures called DAOs. Okay, and yeah, one final pillar, and this is kind of just going into more detail from the last part, is you can actually take the peer review process and navigate it through a smart contract. And of course, the peer review process is like one of the cornerstones of the scientific method. So it's shocking why so little attention has been really paid to how do you streamline this process. And a lot of that process occurs nowadays through the publishing industry, right? Academic publishing. And it can be pretty difficult for researchers to connect with each other, especially ones that have expertise in each other's fields, that's like required to actually perform good peer review. So instead, we can use smart contracts, which are basically just programs, pieces of code that run on the distributed computer that is Ethereum or other like scripting blockchains, to regulate that process programmatically and highly efficiently. So for example, two researchers that might belong to the same DAO, let's say Vita DAO, they're both longevity researchers, they have very niche expertise. They can view each other's profiles through the Vita DAO platform and see, okay, this person is an expert in my field, and then contact them, or literally just click a button and like send in a request for a peer review. And then the research itself, as well as all the terms and requirements and the data, they're all sent directly to the other researcher programmatically. And if the researcher completes their task of peer reviewing that work, the smart contract can automatically execute and deposit a certain amount of, let's say, reputation tokens or cryptocurrency into their account, which was provided by the person demanding the peer review. So this kind of system can actually also double as a decentralized research repository, which, hold on. Oh, I went too far. Where things like papers, peer reviews, metadata, it can all be stored on decentralized storage solutions like Arweave or Filecoin, which basically removes the reliance on like a few companies like Google or Microsoft or Amazon who have like centralized servers, which is probably where we want to put some of our data, or not all of our data, in the hands of a few. And with a little bit of imagination, like this kind of DAO system and navigated through smart contracts can easily like mold into all sorts of different things. For example, you might have to have users like require a certain amount of reputation tokens before they can access certain papers or certain resources, or demand certain tasks to be completed by the community. And it can also push out the academic publishing industry out the window as a whole, really. Like researchers, users can upload their work directly to this DAO framework or some other decentralized storage solution. And then a bunch of just different smart contracts programmatically like enforce maybe, let's say, like a readership fee to access like papers, to access work. If you want to access that work, you would just pay like, let's say, a small amount of cryptocurrency, and that gets redirected directly to the researchers and the people who actually made the work themselves, rather than funneling first through publishers and editors and writers and everything else. And just one final last like little idea. This is a little bit more pie in the sky, but it's still interesting to know about. Instead of citing only like paper names and publication info and like authors' real names, we can actually cite Ethereum addresses of the researchers whose work we relied on, which is interesting because that would actually place the network of citations all on a blockchain. And that would be really interesting, just like from a like data analytics perspective, because you can actually see exactly which paper cited which, and you can just construct this whole topology of the network of research, and that would be pretty awesome. Okay, so yeah, just a quick summary to recap. We looked at modern science as an industry, really, and some of the many inefficiencies in the process of how research gets translated from laboratories and then into real world impact and value in companies and products and drugs that help people, right? And we looked at universities and how their tech transfer offices are becoming like IP holding companies simply because of like the illiquidity of the patent marketplace, right? Because of how hard it is to take IP sitting in those TTOs and those university offices and actually pulling them out. And for that reason, how an unimaginable number of patents that are potentially life-changing drug discoveries or cures or huge advances in sustainability or material science or anything else, and all that is just like sitting around and expiring and having no impact simply because of how hard it is to, like I said, pull it out. And then, this issue of getting funding is obviously always a challenge for researchers, filling out grant proposals, but also like, pitching to investors, like, this whole entrepreneurial mindset is typically not one that researchers have. Like, that's not their job. Their job is to do research and not, show business value. And those are some of just the issues. And then we looked at how blockchain in various ways can actually solve those issues. We talked about IP-NFTs and how they help solve a lot of those issues by making the IP marketplace more liquid, more participatory, and more peer-to-peer or P2P by eliminating intermediaries and just generally providing a very, very easy go-to-market strategy and just a funding source for researchers, right? They can just wrap their IP into this IP-NFT framework, put it on a marketplace, sell it directly, and almost 100% of the revenue returns to them directly. Then we looked at how we can boost collaboration, build communities of experts, and just generally like reimagine research funding through blockchain regulated DAOs or decentralized autonomous organizations. And then we kind of took a zoomed in look at how smart contracts can actually coordinate the process of peer review in a more efficient peer-to-peer kind of way than how it's currently done in a kind of DAO framework, right? And I think just some final words here. it's easy to be critical of Web3 and things like blockchain and NFTs. They're all kind of good examples of, after all is said and done, a hell of a lot more is said than done. These are hype fields. Like, a lot of people are talking about it, but there's not a lot of people doing it and really showing, like, why does it actually provide value. And I totally understand that perspective. But things like DeSci and the work of companies like Molecule, and things like IP-NFTs and these like Vita DAO, these are some things that really give me hope for the future of blockchain, because it shows that it's actually possible to provide real, concrete, immediate value to hardworking professionals like scientists, and of course in an industry that really at the end of the day benefits all of humankind, right? I mean, science, if we can improve the process of science itself, that would make every other problem a lot easier to solve, whether that's COVID or climate change, or, I could keep going on. But yeah, yeah. Okay, Diana, that's all from me.
All right. Well, thank you so much, Tony. That was amazing, and we are just on time. So thanks for joining to our community, and thanks for all of you that are watching us on live and will watch on demand later. So that was awesome. Thank you so much, and until our next meeting. Bye bye.